Okay, so this is the start of calculus. We're going to talk about a concept called a tangent. And a tangent is where we hit the graph. A tangent actually is where it hits the graph only once. Now that's a really poor definition, because that really doesn't explain really what a tangent is, and it actually can hit more than once if you're far away from it. So really the definition of a tangent is that it hits the graph at one place. And then follows the direction of the graph. So as an example, let's say we take an example of a circle. So if you think about a circle, if you're on a merry-go-round, you're going around on the merry-go-round and you step off the merry-go-round, you're going to travel in a straight line. That straight line is your tangent. And so my tangent at some point, let's say I pick this point here, would follow the curve. It's only going to hit at that one point. It comes along, hits that point, and then keeps going. So right near here, it's kind of almost looks like it's right on that line. Another example, let's take as an example this graph. And so let's look at this point here. The tangent wouldn't be this. So it hits only one place, but it wouldn't be that line because that line doesn't follow the direction of the curve. So the actual tangent is going to follow the direction of the curve, come along, hit at that one point, and keep following that direction. And what I mean by it can hit more than once when we're farther away is notice it hits again here. So it's just following along. It's right at this point that's important. It's following right around it. So this is a tangent. This one is not. So what I'd like to do is I'd like to show you an example of using a program called Desmos. So we're going to go into a program called Desmos. And we're going to look at this program and we're going to look at it to find the equation of a tangent line at this point. So the function we have here is the sine of x plus 0.3x. And here's what this graph looks like. And what I can do is I can actually look at this and notice that I can look at a certain point and I've got a line. This isn't the tangent line, but it's getting closer to the tangent line. And I can see that this is actually what we call a secant line. So the secant line connects 2 points on the curve. And I can find the slope of the secant line because I know what this point is here. I know what this point is here. And then it's just finding the slope of that secant line. It turns out that slope is 0.57. So if I went back to here, I could add in this information. So what I want to do is I want to find the slope, find the equation of the tangent line. Whoops, I don't like that color. So find the equation of the tangent line. To the graph, and I'm going to change the graph that's on that Desmos. I'm going to change my graph to y equals x squared, just because I think the numbers will be easier for us to work with if we're looking at that. All right, so I'm going to go back to my Desmos. I'm going to change my function to y equals x squared. I need to change my graph a little bit because you can't see the whole graph here. So I'm going to go ahead and change my y's, my x-axis to go from, let's say, negative 5 to 5. And I'm going to change my y-axis to go from negative 1 to, oh, I don't know, I guess 6. So we can see a little bit more what's going on. And then I'm going to go ahead and get a little bit closer to the point I want to look at. Okay. And actually the point I want to look at is the point 1, 1. So here I am at the point 1, 1 right there. And I'm now going to kind of look at my secant line. So again, the secant line is just the line that connects up 2 points that follow a line that hit the curve. So here I have the point 2, 4, and here I have the point negative 2, 4, and 1, 1. So if I were to look at this and put this information in here, I now have when x is negative 2, y is 4, and I'm also looking at the point when x is 1 and the y is 1. And I can find the slope between those points. And Desmos has actually found the slope for me, so I can go find that slope. It actually tells me the slope is negative 1. So the slope of this line is negative 1. So we can actually put that information into our table. And we can actually make another column here. The slope between those 2 points is going to be negative 1 between these two. And then we can go ahead and look at other points, and we can get closer and closer in. So I can get closer. Let's say I went to negative 1, and I see that one has a slope of 0. And I can come down here to 0, and I can see that one has a slope of almost 1. I don't think I was exactly on 0, but pretty close. And I can keep moving and closer and see what happens and see what that slope is going to do. I can also go to the other side. I can come up here to when x is 2, I can see my slope is going to be 3. And then I can get closer and closer and closer in. And the main thing is I'm getting closer. And if you notice when you get closer in, you actually become the tangent line. If you're almost there, you actually become that tangent line if you're right on that point. And so we can look at this and see those values coming in, and we can get closer and closer and closer. And you can see as we get closer and closer and closer, my slope was up here at 2, 4. My slope is 3. As I get closer, my slope is getting smaller. And I'm now noticing my slope is actually about 2.4, 2.3, 2.1. My slope is now, looks like almost 2. If I came from the other direction, I can see that my slope is negative 0.5, negative all those things. And then if I start here at 0 and come up, I'm going to notice, hey, we're getting closer and closer. 1.6, 1.7, 1.86, 1.96, we're getting closer and closer and closer again to 2. So we can see kind of what's happening. And if we want to, we could write those values down in here and get all those values in here. But we can see that what's happening is these numbers, as we get closer to 2, as x gets close to 1, sorry, the slope gets close to the number 2. So that tells me that most likely that slope is 2. And so again, let's just look at that real close, just to make sure. We can see that that slope looks to be about 2 right there. And so we can see what's kind of happening there, see what it looks like, and we can get that value. So it looks like our slope is getting closer to 2. And once we know what the slope is, then it's just y minus y1 is equal to slope times x minus x1. We're at the point 1, 1. So it would be y minus 1 is 2 times x minus 1. So we get y is equal to 2x minus 2 plus 1 minus 1. And that would be the equation. Okay? So that's how this all works. We can find more limits. We can find the same idea. This is actually what is known as a limit. We can actually do another example of where we have a cardiac monitor is used to measure the heart rate of a patient after surgery. It compiles the heart member beats after T minutes. And so at 36 minutes, there's 2,530 beats per minute and so forth. You can go to that. And then again, we can find the slope of the tangent lines or the slope of the secant lines. So the slope of the secant lines would be between these two would be, the slope would be 42 is 2948, 36 is 2530 over top of 42 minus 36, and you get that that slope is 69. And then you can keep doing that for all the different ones. So the next one would be same thing. You'd find the slope at 38 and 42. So 42 was again 2948. And it doesn't matter what order you do these as long as the X and Y's are in the same order. And then 38 was 2661. And this time it would be over 42 minus 38. And that comes out to be approximately 72.5. And you can keep doing this for the rest of these. And then we can find out what it is. So if we look at 40 to 42, that slope, and I'm not going to go through it, but you know how to do this. That slope would be 68.5. And then the last one, that slope would be 71. So what I notice is, oops, I got the wrong one. Sorry. This one is 71. I'll have to calculate it. I don't have the value myself. So I'll have to figure it out, but you can figure those out and that gives you your average slope. And then you can average those and find out what your value actually is. And that will give you what your slope is and what you think the heart rate would be at 40 minutes. The last thing I just want to mention is that we can actually think about throwing a ball in the air. So if I were to actually throw a ball into the air, we can talk about what this ball is doing. So here's a ball going through the air. I'm going to stop sharing here for just a moment so you can actually see the ball going in the air. And I'm seeing that ball going up and down into the air. And I can then actually measure how far that ball is going and what time that ball is at a certain point. So I can do this and keep doing this, and I can measure what's happening with this. And the same thing is I can talk about what the tangent line is to the curve that I can create from this, and that will get me the similar ideas. So what I can talk about is I can actually talk about how fast the ball is going. And that gives us a concept of what we call the velocity. So we can actually look at this as being the velocity of the ball at a certain point. And there's different velocities. There's actually something called the average velocity. And the average velocity is the velocity over a time period. And then the more important thing is what we call the instantaneous velocity. And the instantaneous velocity is that velocity at a very specific point. So just like with tangents and secants, these same things are happening here. And it turns out that the average velocity is the same as the slope of the secant line. And the slope of the tangent line is that instantaneous velocity. So as an example, where you might see this is the cop doesn't care when he pulls you over. The police officer doesn't care when he pulls you over how fast you are actually going at over a certain period. The police officer cares how fast you're going at that moment. So we're looking at the idea of what your velocity is at that particular time period, and that's what they're caring about. They don't care that you average less than around the speed limit. If you went over, because you were also going under, the over is the important thing to the police officer. So that's kind of what we're looking at and what kind of values we have. And this is the whole idea that we're kind of getting the idea that what's happening with these, and this idea that velocity is very much related to the slope of the tangent.